In this video, we'll discuss quadratic functions and their corresponding graph, the parabola. So as I just said, the parabola represents the graph of a given quadratic function, whereas the function is the equation for which we would work with to do other types of things algebraically. This function can be written two different ways. We could write it in the general form, which is y equals ax squared plus bx plus c, and this form is great for finding the zeros, which represent the x-intercepts of the parabola. The other form is called the vertex form, where it's written as y equals the quantity a times the quantity x minus h squared plus k. This is great because it tells us where the actual vertex of the parabola is. That's the maximum or minimum value depending on whether a is positive or negative. If a is positive, the graph opens upward, and so it becomes a minimum value. It's the lowest point. If a is negative, the graph will open downward, and that's a maximum point. And that hk for the vertex, we want to pay attention to make sure this is always written as x minus h, and we're going to take that h exactly as it looks. Okay, so it's got to be minus the value. That's always a very important thing here. Now, say we're in general form, and we don't want to convert all the way over to vertex form and have to deal with squaring and all the other things that come with completing the square. We can find the vertex as long as we first put it in general form and make sure we understand what are our coefficients and what's our constant. The x value of the vertex can be found by taking negative b over 2a. Then to find the y value, we would substitute that in for all the x values and then simplify the expression. When it's formally written, we say that the vertex would be negative b over 2a, comma, the function at negative b over 2a. In other words, the substitution. If we want to know whether that vertex is a maximum or minimum, we just need to look at the ax squared value. If it's positive, it's a minimum. If it's negative, it's a maximum. So say we have x squared minus 6x plus 4. We want to find the vertex for this, so we have it in order, and we just got to state our a, b, and c. So 1, negative 6, and 4. To find the x value, that's negative b over 2a, so we need the a and b value, which are 1 and negative 6. So I'm going to have negative 6 over 2 times 1, and that's negative. So paying attention to those negatives is very important, because here I'm going to have a negative negative, which will eventually make it become positive. So I simplify the 2 times 1, and I can say negative times negative is positive. 6 divided by 2 is 3. Now I take my 3 and I'd substitute in for all of my x's and simplify this expression to get my corresponding y. So 3 squared minus 6 times 3 plus 4. That gives me 9 minus 18 plus 4, which gives me negative 9 plus 4, and that's negative 5. So my vertex is 3, negative 5, and since this was a positive x squared, I know that is a minimum value. So if I graphed this, I would see that my graph opens upward and has that minimum at 3, negative 5. Now let's talk about the idea of, well, how do we create this whole graph? First, we want to make sure we have it in general form order. That's the x squared plus x plus the constant. Then we determine the vertex and we plot that on our graph. Next, we try to find other points. This could be the y-intercept. That's when we take the x value and set it equal to 0. If we can, we see if we can solve for the x-intercepts. Here's where we set y equal to 0 and then solve the quadratic equation, where we're either factoring or using the quadratic formula. Now, sometimes a parabola can be formed that has no x-intercepts. In other words, there's no real solutions. If that happens, choose other values that can be constructed. Think about what those may be based on where your vertex is and whether it opens upward or downward. And then we create the parabola through all the points that we may provide. Now here's the nice thing. We actually can graph a lot of things using programs like our TIs, or graphing calculators, or something like Desmos or GeoGebra. So we do have programs that can help us with this. So say we want to graph y plus 5 equals x squared plus 4x. First thing we'd want to do is rewrite this so that it is in appropriate general form order. So that would be y equals ax squared plus bx plus c. So we need to get the y value by itself. To do that, I'm going to subtract 5 from both sides, and then I now have my general form for this quadratic function. Now I can find the vertex because I have my a, my b, and my c value. So I'm going to substitute in my a and my b to find the vertex. So that's negative b over 2a. So that's negative 4 over 2, which is negative 2. Now I have my x value for the vertex. To find my y value, I just substitute it back into the equation. So that's negative 2 squared plus 4 times negative 2 minus 5, which is 4 minus 8 minus 5. So I get negative 4 minus 5, which is negative 9. So I have a vertex at negative 2, negative 9. Now I can look for other points. So I have my equation, and I can say, well, I know that my y-intercept is when I plug in 0 for x. So 0 plus 4 times 0 minus 5. So my y-intercept is negative 5. It's nice to have another point. Now let's look about the x-intercepts. So I can say I have x squared plus 4x minus 5 equals 0. So if I think about how can I factor this, well, I know I'm looking at something that multiplies to make negative 5 but adds to be 4. So that would require a positive 5 and a negative 1. So I'm group factoring here. So I group my first two and I group my second two. I pull out the x from the first set and the 5 from the second, and that's great because I get x minus 1 and x minus 1. So my two factors are x plus 5 and x minus 1. Now I set each of those equal to 0, and so x is negative 5 and x is 1. Those are my intercepts at negative 5, 0 and 1, 0. So I've got all these points, a vertex at negative 2, negative 9. I've got my y-intercept at 0, negative 5. And I've got my x-intercepts at negative 5 and positive 1. And now I can draw my parabola through those points. And there I have the parabola for the function y equals x squared plus 4x minus 5. Now I can also construct a parabola from the vertex form. And what's nice about this is that I already have my vertex as long as I'm writing this as x minus h. My vertex is hk. Then it's just a matter of finding the other points there. So it's important to recognize that hk means I'm shifting my parabola h units to the right and k units up from 0, 0. So if it's a negative h, that means really I'm shifting to the left. And if it's a negative k, I'm really shifting my units down. So then I find the same types of points. Can I find the y-intercept when x is 0? Can I find the x-intercepts when I make y equals 0? The key, though, is if I have this here, I'm finding the x-intercepts, I'm probably going to have to expand the x minus h quantity squared and then use something like the quadratic formula or factoring to be able to find those x-intercepts. Now, it is possible, again, to have no intercepts. Like if my vertex is above the x-axis and it's positive opening upwards, it never crosses the x-axis, therefore there's no intercepts. So I need to find other points that could be helpful. And then I'll create my parabola through the points that I have. Let's look at an example. Say I have y equals x minus 3 squared plus 1. Well, my vertex is right here. It's hk, and I'm in the form x minus h, so I don't have to change anything. That means that it's 3 and 1. So that's my vertex. Now I'm going to think about some other points. The y-intercept, I can plug in 0. So 0 minus 3 squared plus 1. So that's negative 3 squared, which is positive 9. 9 plus 1 is 10. So I have a y-intercept at 0, 10. Now to find my other aspects, I have to think. With my x-intercepts, there can't be any x-intercepts because my vertex is above the x-axis and it's opening upward. So that vertex is a minimum. I'm not going to ever go below 3, 1. So I need to find some other points. So let's try 2. Since my vertex is over at 3, let's go to 2 and let's go to 4. So at 2, 2 minus 3 squared plus 1. Negative 1 squared is positive 1. 1 plus 1 is 2. So that tells me that my x value is 2, my y value is 2, so I can plot the point 2, 2. Now let's try 4. So I'm on each side of my vertex. So 4 minus 3 squared plus 1. 1 squared plus 1. 1 plus 1 is 2. So I've got 4, 2 as a point on the other side of the vertex. Now I can start to form my parabola. So let's graph the points I have. The vertex at 3, 1. Then I have my y-intercept at 0, 10. Then I have my points at 2, 2 and at 4, 2. And I can start to form that graph and keep it symmetric around the vertex. And there I'd have the graph for y equals x minus 3 quantity squared plus 1.